James Law is a vice president at SCS Engineers in the Solid Waste Division and International Services. He has over 35 years of experience in civil geotechnical engineering and solid waste management on both national and international projects and different municipalities and different cities and so on. He serves also as a board member of ISWA, and he's the chair of the ISWA working group on landfills. He's also the chair of the task force on closing dump sites. So James, over to you. We can see your presentation, and I think we can hear you well as well.
Very good. Thank you, Aditi, for your kind introductions one more time. This next sections, I will be talking about landfill rehabilitation. Mention some of the technologies and methodology dealing with closing dump sites, as well as some examples and case study to share with you guys. Here's by the way, I haven't had my lunch yet or dinner, so I will be talking real fast. Overview of my topic. I will talk about impacts of the dump sites, kind of repeat what I have in the previous section, but in a different tone. Then I will then present some of the rehab technology, technical challenges. And then after that, I will mention some of the closure system options for dump sites. And follow after that will be examples and case study. So maybe Carlos know where this site is. Anyway, this is a commercial site in the way back when it was still open. And in the foreground of this big landfill, the landfill, by the way, is sitting over a swamp, like soft foundation soil. And you can see this dump site. This is called what we call tension cracks. When you see this thing at your dump site or landfill, be sure to pay attention to it and plan on doing something about it, because this is the good indicator of your slope is going to go downhill. Actually, this one already is, because the crack is so big. I feel like I should make a little quick introduction of dump site operations. As you all know, dump sites, open dumps is categorized as waste that is not covered and is spread out the entire surface. There's no application of soil cover to dress over the waste. So it's basically exposed to environment, weathers, and people. And very often, fire is very common in open dump scenario. And there is no liner system at the bottom. So which means any liquid that goes through waste, which become leachate, and leachate basically will leak through, go downward by gravities, go to wherever it goes, and eventually find its way to the groundwater system. In open dump sites, there is usually no compaction. Waste is very loosely placed and then maybe pushed around by a dozer. And tomorrow, the discussion, I will talk more about operation, but the leachate and gas basically not managed. And you have an unusual, unmanaged, very steep slope usually, because when they push the waste over the edge of the existing slope, and over time, right, that slope just getting steeper and steeper. There's a lack of security, highly accessible to waste pickers, and therefore you have this issue with people living on the land, on the dump site, and exposed to all the dangers and hazards associated with the dump site operations. Vectors like dog, birds, and other animals, very common. Open dump has humongous impact on the environment, public health, and economy. Let's talk about the environment. And as you can see from this little cartoon on the upper right, you have open dump waste is being placed there, and anything leak through, you get soil contamination, and through there you go down to whatever the groundwater is, and then it would affect basically all the fauna and flora around the landfill. And then you have contamination through air that go up, evapotranspiration, and then surface water that run downhill to any surface water body. You contaminate the lake or the rivers and so on. And so it really, environment is really totally impacted by open dump situation, particularly when there is no liner system below it. And then with regarding to public health, of course, if people drink water that is contaminated, it will affect you. And then the disease also is an issue that people have to deal with. One thing about the waste picker, it's because they are at the site picking through waste, and so their health and safety is there's a huge potential that is being compromised. Now, internal economy, as you know, costs money to maintain public health. So if the public health is impacted by it, it's going to cost individual or the government money to deal with how to keep them healthy. And then there is the cost associated with the environmental impacts, potable water, for instance, and how about the farmlands being contaminated? That all impact to contribute to cost to remediate it. Sometimes people say that dump sites cause them to lose the values of their land or the real estate around the dump site, and so it is, it is a potential cost item. Then, of course, if you identify some contamination leaving the sites to the neighbors, adjacent properties, there will be some kind of cleanup cost as related to it. And lots of resources, if you cannot rehabilitate a dump site into something that's useful, there is a loss of resource there. Open dumps. Okay, open dumps are a danger to communities, and I want you to visualize this. Okay, to the communities, to the environment, and agriculture if there is farmland nearby, and as well as economy. They do generate toxic gas and odors into the air, and then the leachate into the ground below, which can seep to some critical water table that your home may be depending on well water. So it impacts negatively on the health of the people, as well as all the plants and animal around the site. So it does impact the quality of life of people and the wildlife as well. Now there are drivers and demands for ending open dumps. I think earlier session we did touch a little bit about it, but here is a potential list of things that what is important to people so that they can then say, hey, no more open dumps. First on the list is public health. We talked about that before. And then environmental protection, kind of obvious. Bans on open dumps. If there is, let's say the government reinforce this, and they need to come up with some alternative solutions to make sure that let's say waste pickers' livelihood is not impacted by it. So one of the other drivers is improve of the quality of life for obvious reason. If the dumps is being managed, and so there's no contamination of air, water, and soil, people living around it will have a better quality of life and health as well. So public perception about open dumps, I think most people don't want a dump next to their home, something called NIMBY, not in my backyard. And for that obvious reasons, a lot of people resist to opponent to dump site operation is that nobody want to see it in your backyard. And the other items I add on the list is the end use of the dump sites, because this one sometimes it will serve as a good drivers for people who wants it, because if you convert a dump site into a park or passive use, and then I think people are more accepting to the fact that, hey, we don't need a dump site. Let's move on to other alternative way of handling waste. This kind of lead to probably sanitary landfills or other way of handling waste. So reclamations is sort of a solution to haphazard dump sites, that was abandoned or end is useful life, and you want to do something to recover the land, whether you use it through a passive use or active use of that piece of land. And in US, it's very common to convert it into a golf course and public park, that sort of things. But you obviously, you need to design everything, make sure that, the user is not impacted by the gas that is still generating from the landfill or dump sites. And here's an example of a golf course that I just talked about. And, if you have a huge piece of land, it's naturally, golf course is a sort of passive active use, but then is more for recreation, but it also generate income for the landfill owner. The other use as a passive use is use it as a public accessible park. You can fly a model plane there or fly kites and all kind of other users you can be. We have a site that converted into athletic fields, like football field, for instance, or tennis court. These are more commonly end use for a landfill. And you may see this coming, solar panel on landfills. In the Northeast US is becoming very popular there because for the landfill that is already closed, the owner is willing to lease it to the alternative energy companies that use solar panel to generate power. And so it's a win-win situation. Now, here's a list of technical issues and challenges at dump sites. As you can imagine that dump site has an inherent problem because waste is not covered because they don't apply daily cover soil when they operate the landfill. So as you see the pictures, animal is kind of feeding on the waste. Also, it's always a steep slope of somewhere in the dump site is always, and like this one is almost near vertical. But and because of the unmanaged slow configuration, and stability is always an issue, and it's really depending on. And you may hear a story about some dump site fail because of going through one or two monsoon, a lot of rainfall that comes down and then causes the failures. This is just a very typical claim, that why landfill fail. Now, in terms of stormwater control, there is almost non-existing at the dump site, no compassion of waste, and no record of what is in the waste. You could have some hazardous waste deposit, but nobody really control it, inspect the load coming in, so you don't know what is coming in. And waste pickers and scavengers, that is, I think most dump site, you have that. No security fence prevent people coming in and out of the landfill. And then odors and gas, leachates, that is just basically a common issue. And so when you close, and usually there's no closing, closing or closure plan in place. So when you deal with dump sites, and especially if you're thinking about closing it or terminate the use of it, and the latter part of the list is a common issue that you had to deal with. You had to deal with leachate, you had to deal with gas, and you had to deal with these stormwater issues. So these are all the things that you need to address when you do decide to close the dump site. Okay, here I try to illustrate saying that technical challenges, there is always a solution for every problem. Isn't it true for in our life? There's always a solution, so long as you spend time thinking about it. And now, before I start this, and I just remember that I do wanted to compliment our participant from Oman. Just give you a little history about their countries, that they basically, and this is for people who actually want to address dump site, closing dump site, and then convert it to sanitary landfills. And Oman has successfully closed all their 300 plus dump site, and in few years time, they basically convert everything to regional sanitary landfill. I think there are about 30 of them. So the success story is out there, and so long as we can reach out to hear their story. And yeah, the BIA has been a platinum organization member of ISWA. So I'm sure they have stories to share, and I would love to get hold of their story, so next time I can share with other people. Now, let me quickly overview the technologies and methodology to manage open dumps, and this is more like management, meanings that whether you decided to leave it open or you want to close it. So first, which I'm not recommending, is business as usual. So in other words, it's a dump, it's always a dump, and nobody want to do anything about it. And so if you ask them to do something more, right, then they would say, why bother, right? It's a dump site. So number one, it's kind of strike the core of our task force on closing dump site. It's not going to be business as usual. If you want changes, if you want to change people's mindset, we need to deal with it. So second is to improve the operation and management to reduce the impact due to from the dump site. Now, I listed 3 different ways of closing dump site, or maybe convert it into a control field over time before you can go down to number 3, which is basically set up a new sanitary landfill. There are 3 ways you can close dump sites. One is you can close in place, which means whatever you got now, you will try your best to cap the dump site such that there's no animals or vectors get into the waste. There's no stormwater penetrate into the waste becoming leachate. And you may try to collect some kind of gas as a passive collection system, or you can burn it, flat it off. So you do something with it. And second is you plan on closing. At the same time, you also try to establish a control field landfill situation. And this option is basically, let's say you have not designed or construct a new sanitary landfill. You need some kind of interim transitional solution. So which means you will probably move to the next step is to do a control landfill or control dump site. It's basically you select an area and then try to line the area so that you can try to collect the leachate and gas later on. So this is sort of a step of improvement from open dump. And now the third item of closure of the dump site, which is a very time-consuming and costly activities. In other words, this is dealing with removing all the waste from the site. It's something in the technical term is called landfill mining, and I think there's another term out there called bio mining. In other words, you just try to, sort through the waste, separate into different materials, and get rid of that whole dump site. And I included here because I know that in India this option is being considered. So it will come out in the later part of the presentation. But so anyway, third is to establish a engineered sanitary landfill. And now I'll go into more specific about closure of waste in place. So basically you put soil cover over it. As I explained it before, that's to reduce the exposure to waste and also avoid people, waste picker or scavenging happening. And then because with the soil cover, you somewhat control the odors as well as infiltrations through the waste. And now because of the cover soil, your ability to collect some kind of gas increases because now not the entire landfill surface is emitting gas, but you kind of concentrate the gas, try to collect them for whatever use that you have in mind. And with the soil cover, you actually will promote vegetation growth, as well as some of the post-closure activity, like I mentioned before, the passive use converted to a recreation park, that sort of thing. And now there is a minimum of 250 millimeter of soil that need to be compacted. And the idea here is to create a firm base and low permeable soil base to prevent infiltration, minimize infiltration. Now, control field here, it implies that you are applying daily cover. Your daily cover operation becoming a norm because the importance of daily cover is to control generation of leachate and accessible to animals or scavengers. And also you maintain operation slope. This is 1 to 3 slope, so that it is not too steep, and you try to maintain that. And also you compact waste like 300 millimeters thick each layers. So the idea here is to get better compaction of the waste. And then security of the site, you put security fence up, and also you record what is coming into the landfill through scale house or scales, the station that measure the weight of the vehicle coming through. And then you also collect gas and combust it as an open flare. And then one one of the important thing here is the tipping area or the working phase area. You need to keep it small so that you are not exposed to the weather elements, as well as easy to control and cover up and at the end of the day. And litter control is important as well, because in area that you have a lot of high wind situation, then you want to make sure that you are able to control that. So this list basically, if you do all this, right, it's kind of give you an idea of control landfill. It not necessarily imply that you need to have a liner system at the bottom, but if you do all these operation activities, then you have better managed of your compared to open dump scenario. And moving waste from the site, which is mining, this is very elaborate. People who do this option is either that piece of land has a very high value in terms of real estate, or the politician basically say, okay, this mountain got to go, So there's a lot of reason why people end up doing it. It's definitely not about economy of try to mine the recyclable material. That it usually is not the driver. It's other reasons. And now when you do landfill mining, obviously one of the risks is to run into hazardous waste, like I talk about this morning. And then I think I already mentioned about the valuable development land opportunity. When you free up that piece of land, it becoming available for developments, for high rises and commercial use. Of course, part of that will be you have to remediate the ground below it if it is contaminated. So there are some works need to be done before it can be used for development, where you have people located above it. And now, internal establishment of a new sanitary landfill. I mean, this list of things is pretty much summarize everything about establishing a sanitary landfill. You need to be permitted, planned, and engineered to a specification that meets the local needs. Okay, and most of the states in the US, at least every state have their own regulation that governs you how you're what is the minimum requirement or the component of the sanitary landfill needs to have. And this is just a list of things, you need to be engineers, you need to collect leachate, you need to collect gas, and then you have to have a sound operation practice. And that's very important. And then you need to have the ability to monitor your landfill, monitor the gas migrations, monitor the groundwaters, and some site, if you're near the neighbor, you need to monitor the sound and also the odors that's generated by the landfill. So, there's a lot of elements go to it. But if you add all that up, right, it is defined as a sanitary landfill. And then on top of that, you need to have a closure plan, post-closure plan, and then the long-term aftercare plan of the facility. So everything got to think ahead of time before you run out of airspace. And in the US, the post-closure care period is 30 years. I think somewhere in Europe, some of the European countries, maybe 50 years. So it's all varies, Now let me spend a little bit of time talk about the cover systems. And the first one, what we call prescriptive cover systems, is also referred to resistive barrier layers. And if you look at the pictures on the right-hand side, there is a 45 centimeter of barrier layer. And this is a layer that would reduce or slow down the infiltration coming from above and then into the, into the waste below it. And so this is sort of minimal. If you have a dump site and if you want to close it, you need to supply, first of all, you need to have a foundation layers, to give it a stable base to put the barrier layers and topsoil above it. And then the topsoil layers is also called erosion layers, typically about minimum of 150 millimeters, something that is able to support the vegetation. And then now, second cover material is called evapotranspiration cover, which in short called ET cover. And this one is basically, it's a system that you design to store the infiltration and then release it through evapotranspiration process. In other words, what is stored in this cover soil, eventually it would release to the air by, solar radiation or plant, the root system that will suck it up and then use it or release to the atmosphere. So this is fairly common if you are in an area that is semi-arid, and in other words, your weather is kind of dry most of the time, and so there's not much rainfall. But if you are in if you're in a tropical region, right, then this may not work for you. Now, the third cover system is basically you upgrade it with liner system, and this one could be used for a dump site that wanted to upgrade it to a control dump site operation. In other words, if you want to install a liner system before you continue on practicing putting garbage over it, and you could consider putting a liner system in here. Now, like in US, a lot of old landfill, this is when the US landfill was converted to dump sites to a sanitary landfill. There are some the old site that they want to continue operating, and they will have to put in this liner in order to meet the regulations. And this is very typical, like when you're transitioning from dump site to sanitary landfill, because the idea here is to show some level of control. Whether are you handling the leachate? Are you handling the gas, right? And that for that reason, right, the liner requirement is placed here. And there is a additional layer they call drainage layers, which you can use geocomposite drainage net or just a sand layer that would add to collect the infiltration and then prevent it from going further down. Now, let's go to the case study that I like to present. This particular dump site is at the highest point is about 60 meters. So it's pretty big mound. And HIRIYA landfill is located in Israel, in Tel Aviv area. And we were involved in the rehabilitation part of it. We were engaged at that time as a geotechnical engineers at the time. And they have architects and structural engineers, and there are a lot of disciplined people working on this project. And the footprint of the landfill is about 40 hectares, and it has about 16 plus million tons of 16 million cubic meter of waste. operate between 1952 to 1998, and they did have some site control regarding drainage, and they also installed some biogas well, and they have about 1 to 3 meters of soil cover on top of that at the time of pre-closure. Now they have a failure here before, back in 1997. I think maybe some slide may show it later on. But here's the plan view of the site. You know, the site is kind of located in between two rivers, and so you kind of, to close this particular site or to rehab because the boundary by two rivers, right? So it took a lot of engineering work here to come up with idea how to rehab this dump site. And this picture shows a slope in the northeast direction. As you can see, the slope is fairly steep, and that's the river going around the landfill. And this one illustrates that your slope is at the steepest point is 1 to 0.67 horizontal, and the rest of the area, the rest of the slope here is 1 to 1.2. It's very steep, and we did analysis, and it came out to be almost close to failure. Okay, and that probably explains why some of the slope actually slip. Now on the south side, they have a transfer station located on the south side. So east and west, they have river. South side, they have transfer station. So as you can see, you know, this presents some technical challenges in terms of how to close this dump site. And of course, you see veneer instability, like very shallow failures at the near surface is very common, because, you know, waste or cover soil will not hold up by itself, because you are defying all the force of gravities, you know. So it will go, you know, if you add some water to it, it eventually will go. And then, you know, you got, when the cover soil is gone, you expose waste, right? So it's becoming a vicious cycle, you know. So in summary, the slope is very steep. Average, you know, I think average of 1 to 1.4 to 1 to 1.5. And then average height is 60 meters. And as you see, the calculated factor of safety for the slope is very low. And when you have a seismic, even small seismic force, you go below zero, below 1.0. And there was a deep-seated failure in 1997. And as I said before, shallow failure happen every year. So here is the stability recommendation. I think the item I mentioned in blue here basically say that for, you know, standard practice, you wanted to maintain your side slope at 1 to 3, maybe to 1 to 4 ratio, and then the benches is like 5 to 10 meters. I mean, this is very common, right? So, and then steep slope, you can reinforce this steep slope with geosynthetic material. Now, so with the to rehab this HIRIYA landfill, we kind of have to reconfigure the slope for stability purpose. You know, as I mentioned before, deep-seated is is problematic. It basically, when you have that kind of failure, right, you would jump over that river, you know. So everything stop flowing. So then you have a problem. And then I think I believe they have farmland next to it as well. So one thing about designing to rehab is we also want to design design slope and the top deck area to be able to support vegetation. And the city have the plan of converting this into a beautiful park. So which means the covers system that you consider is becoming very important. You know, how you're going to cover with a liner system, as well as enough soil to sustain vegetation, and at the same time control stormwater runoff. So this is it's a conceptual drawing. This is how they envision on the northeast side. They are going to convert this big like a park with landscape, you know, a lot of landscape features in there. And then there's a walking trail. You can go there and walk and jogging, whatever. So this is sort of an initial conceptual plan. And now, because of the steep slopes, there are 4 options that we consider here. The first option is that we can either maintain the slope as the same as before, but then try to reinforce the soil that we add on, try to reinforce it so that that would enhance it from failing. And then the second option, is by excavating this or flatten the slope, as you can see on the picture here. This involved with, you had to excavate a lot of waste out of there. So, you know, in a lot of situations, that is least of the desirable methods, because then you had to deal with where do you put the waste that you excavate. And then the third option is to fill over the steep slope with something else. In this case, they are considering either using soil or construction debris, demolition fill in this triangle area, so that you know they can flatten the slope. My battery, kidding me? Don't quit on me now. Okay, so flatten the slope to 1 to 3.5 to 1. This would take a lot of material to fill it. But then if you let's say if you have source of C&D fill, it's becoming a very attractive option, because then you kind of handle the C&D waste. At the same time, you buttress again this slope to make the slope even more stable. So, you know, that is probably a win-win situation there. And then the fourth option is to do combination of flattening the slope, and also in this case, you cut off, excavate some waste up on the upper slope, but then you fill in the bigger part of it. So these are the 4 options, okay? And from this is a profile that kind of show you a potential profile, how things gonna look. Like I said earlier, this is existing slope, and then they fill in with a C&D or fly ash material. And as you can see, the final slope is bench, and also maintain at 1 to 3 or to 1 to 3.5 slope. And then they created, now this is the existing river near the existing waste. They're gonna move this river way out there. And then they're also gonna provide a tow berm to contain the C&D fill. And in between the tow berm and the new river, they're gonna provide access road. So as you can see, they're gonna kick out the tow quite a bit. Like for 1 to 3 slope, you'll go out about 140 meters. And this is another section showing similar section, except showing that they plan to put a liner in between this area that they generated to contain the C&D fill. So obviously, you know, to put a liner in here, this will add cost to it, but at least they have a liner system for the new C&D waste, so that any leachate coming through, they can collect and treat it. Okay, and so as you can see, you know, this is pretty heavily engineered, and it's a lot of things take into consideration, and especially if you try to rehab a dump site properly. Yeah, you just cannot, you know, walk away from it. And now in terms of the lining details, and this is just one out of, I think there's a lot of section generated for this, and almost along this section line, almost at every location, they have a liner system called for. So like the upper detail here that you see, they have benches created, and they can grow trees. And as you know, tree roots go much deeper, right? So the soil, the amount of soil they need here is much thicker if you plan to grow trees, you know. And if it is in a flatter area, then the thickness is much less. So there's a lot of detail going to the design part of it. And so to the left is a architect view of what it's supposed to look like after rehab this particular site. And as you can see on the south side, they have a transfer station. So they'll continue to use it as a transfer station, but then they also convert it into a recycling facility. So they will still operate out of it. And then there's a recycling park. There's a lot of nice features they put in there. But you know, on top, you know, it's just it's a park basically. And like I mentioned before, see the line in red. This is that's the location of the solid red is the existing river, and where they are going to relocate is the dash line or around the landfill. So basically, they're going to move this river outward in order to accommodate flattening of the slope. The double green dots line represent the minimum distance of filling. So anything between the green dotted line and the red solid line is the additional fill they're going to place against the steep slope. So from this case study, as you can see, that if you operate the dump site as it is, creating very steep slope, eventually it's going to come to you. May not be to you now, but 2 generations later, someone's going to pay for it to make correction. So the message here is that we better do things right in the first place, right? And if this is why the task force is tasked to say, hey, you know, let's stay away from dump site. Let's move into other option of handling waste. Sanitary landfill obviously is, you know, ideal, but okay, here's a picture of before and after. As you can see on the right side is the picture taken during the 1997 slide, and everything looked pretty messy, right? But then after closure, this is probably close to finishing. The picture was taken, but everything looked pretty organized manner. And now let me jump to another case study, and this is if anybody goes visit the New York cities, they have a landfill called Fresh Kills landfill. It has been closed the last 15-20 years maybe, and the footprint is about I think it's about close to 2,000 acres, so it's about 900 plus hectares, and they say the site is about 4 times larger than the Central Park. So you can imagine it's a big piece of land and previously dump site. And so the closure plan, actually, it took 30 years to close this site, and now they're into the 20 years. So every 10 years, they will close a portion of the landfills. and you'll take 30 years to close this particular site. And as you can see, the end use of the closure site is predominantly recreation park, but it includes a waterfront recreation area, some sport field, golf, archery, picnic areas, and equestrian facilities, wildlife refuge. So you name it, they have everything there. Trail, running, walking trail, mountain biking, and they also preserve wetlands. Of course, they're boardwalk. You can observe wildlife out there, and they even house an area. I don't know which section now. The debris coming from the 9/11 that go to one of the mounds. Freshkiln landfill, they have 4 big mounds, and one of the mounds is a memorial park for the 9/11. Now coming to the closest to us, as Aditi and I know about this site, and it's kind of it is a man-made disasters in city of Delhi, and in the city of Delhi, they have about 3-4 landfill of similar scale, and this one is in East Delhi, and the height is about 65 or 68 meters, and they have one failure before. If you see this color shaded area, this is the area that they failed before, and this is when they try to remediate it. And this particular site, it is a political driven wells that they decided to do bio-mining for this whole site. And in a simple language, is that they are going to make this dump site disappear. So if you stand on top of the landfill, I mean, you can see, there's a lot of buildings all around the landfill, and then one side they have fish market and slaughterhouse, and basically people daily activity is very close to the this dump, and so the failure occurs on this other side where there's a canal and then there's a road. So I'm glad I was glad that the failures happen on this side where it is not the fish market. So now in terms of proposed bio-mining, of course, first thing is, it seems to me that it's going to cost a lot of money, and you also need a excavation plan. Because how are you going to excavate that mound in phases or certain sequence is very important. I think it need to be evaluated before you can go and dig that mound. Otherwise, you may create a failure during the operations, and the excuse me, and the health and safety of the publics and the workers, as should be number one priorities to be concerned about. And the other question that you may ask is that, okay, if you process this dump site, the waste, and where are the sorted material goes? Is there a market for it? And is there someone wanted to do something with it? And I think those are all the questions that you need to ask yourself. Let's say if you have a dump site, you decide to go this route, and you certainly want to have a master plan, to make sure that everything is being considered and everything has a solution and a plan B, plan C to it. Otherwise, you may create a huge environmental disaster, in hands. So, nevertheless, it is not. It is a method to consider if someone wanted to undertake this, because I'm pretty sure this piece of land is very, very valuable. It's in the middle of the big city. Now, I have a couple of slides talk about the some alternative cover material, and this one is about bio covers, and this particular solution is for a dump site that wants to close the dump site, but they don't have soil to close the dump site, but then, you know, let's say they have plenty of end products from a mechanical biological treatment plant. So the picture was taken from a site in Argentina, and they decided to put the end products from a MBT plant on the surface of the landfill. So they apply the first course they put down is called they call coarse layers. In other words, these layers serve like a drainage layers, and then after that they'll put a finer grain product from the MBT plant on top of that, and then, you know, and then they'll monitor and then they'll seed it, of course, and then, you know, and then you know, over the next growing season, you know, we show that everything is green there. So in their demonstration here, it seems like a good option for them. And the next cover system that someone can consider is assuming that, you know, this geosynthetic closure material is available and it is cost effective for you. And also, you know, it makes sense internal environmental performance. But of course, you know, before you decided to go with the exposed synthetic cap, you need to have an idea in your mind what you want to do with this closed area. If you choose to do a synthetic closure systems. And like some site in US that they have successfully installed a synthetic cap, and then on top of that they put solar panel on it for solar energy. So, you know, in that sense, you know, if they do their due diligence and feasibility study, they feel that everything makes sense to them. So that's why they went ahead and do a synthetic cap, and then with solar panel at the surface that is facing, like in the US, facing south, you get most of the sun. And with that, I think, let me do a real quick summary there. And the dumpsite rehabilitation technical problems and challenges are very easy to identify by any available traditional methods out there. However, the solution need to consider local practice, social conditions, political influence, and cost and regulation reinforcement if you have one. And the end use, whether active or passive use, can benefit everybody in the regions. Then the last summary I have here is the use of biocover and geosynthetic cover may be feasible when considering material availability, cost benefit, and environmental performance. And of course, you know, the installation experience is very important here for a successful closure project. Okay, with that, and I hand it back to you, Aditi.